Hello, good evening. Hello,
Good evening, sir.
good evening.
Good evening.
Whether it is audible and visible, both?
Yes, sir.
Okay,
Yes, sir.
right. Okay, thank you. Okay, let us start today's class. So yesterday we have discussed how to solve a system of linear equations using an iterative method. But we have discussed two methods. One is called Gauss-Seidel method. Another one is Jacobi's method. In both the methods, the starting the concept same, a small change only. Let us once again we shall recall the method. So, but these two are iterative method. We should know first of all what in by iterative method. Iterative method means it's a method where solution is not directly obtained, but through a sequence of iteration. That means titration we can say. Through a titration or iteration, we get the answer. So this type of methods are called iteration method. So let us discuss two methods simultaneously because the starting that point in both the case methods only the same. So suppose that a system of equations given, we shall recall this equation. Yesterday I explained, once again we shall recall. Suppose the first equation a11 into x1 plus a12 into x2 plus etc. a1n into xn is equal to b1. There's a first equation with the n unknowns like that. Second equation, third equation. Suppose there are n equations with n unknowns. But in an iterative method, there should be a condition for that. If that condition is there, then only can get a solution or that sequence of approximate solution converge solution if this condition satisfied. That condition is this system of equation must be diagonally dominant. So diagonally dominant means the first equation, the coefficient of the first variable. So there are variables x1, x2, etc., xn. First variable is x1. Its coefficient is a11. So this should be larger compared to the remaining coefficient of that equation. The first equation remaining coefficient are a12, etc., a1n. If I add all these coefficients, that sum should be less than a11. A11 is the coefficient of the first variable in the first equation. In the second equation, the coefficient of the second variable that should be larger compared to the remaining coefficient. So in the first equation, a11 should be larger. The second equation, a22 should be larger compared to the remaining coefficient. And last equation, an should be larger. So then it is called diagonally dominant. If this condition satisfied, then only can get the converging approximations through this iteration method. Sometimes in the problem, it is not satisfied. You have to rearrange the equation such a way that this condition is satisfied. Once this equation is satisfied, from the first equation, we can write here in the first equation, coefficient of first variable should be larger. So this variable you write in terms of the remaining variables. That means take all this variable right hand side divided by a11, that gives the value of x1. So first step in this iteration method is rewrite the given system of equation in this form. The first equation, find x1 in terms of the remaining variable. We can write like this. From the second equation, write x2 because coefficient of x2 is larger here, a22. So take x2 in terms of the remaining variables. We can write like this: x2 is equal to this b2 minus a22, x2 minus etc. a2 and xn folded by a21. That gives this one. Like that, etc. Continue like that. From the last equation, you write xn in terms of the remaining variables. That means you take all the terms to the right hand side, then divided by a and nn, that gives the value of xn here. So this is rewriting the given system of equations if it is diagonally dominant. So first step in these two methods, I'm explaining both the methods simultaneously. So in these two methods, first step is same, writing that unknowns in terms of the remaining variables using the given that system of equations. After that, both the methods, what the first step, second step is assuming something for the solution. We have to find what is the value of x1, x2, xn. These are the unknowns. You are assuming something. Sometimes in the exam they assume that initial root as 1, 3, 5, etc. If it is not given, you are free to select. What you can do is, if it is not given, you assume that all the variables are 0. x1, x2, etc. xn 0 means in the beginning we are assuming that there is no profit or no loss for that problem. So take the initial approximation. There's the second step. Now third step is iteration process. I'll write for both the methods simultaneously. First, I'll write the iteration formula for the Gauss-Seidel method. In Gauss-Seidel iteration process and Jacobi iteration process, there are two methods, right? In both the methods, the first two steps same. First, rewriting the given system in terms of the other variables. Then we are assuming an initial root for the system. The Gauss-Seidel iteration process, this works like this. For the first variable, that equation written, the value of the first variable in the n+1th iteration, it is obtained by substituting the values of the remaining variables in the previous iteration. So this is n+1th iteration, this is nth iteration. So from this, you get the value of x1, right? Next, for x2, what to do is, for all the variables, same nth iteration values you have to give, but for the first variable x1, you give the value what you obtained in the first value in the first iteration. That means we got the value of x1 using the first equation. That value substitute for x1. For the remaining values, all the new old values assumption, x3 to the power n, etc., xn to the power n. That means the answer obtained the nth iteration you have to substitute to get the solution for x2. You continue like this. Similarly, for x3 variable, what to do? For x1, x2 from the previous two equation got, that you have to substitute. For the remaining variables, the same, the answer you obtained the nth iteration. You continue like that. At the end, last equation, its values obtained by substituting all the values you got in the previous equations. From these previous equation, what you got, that you have to substitute. So this completes the first iteration process in Gauss-Seidel iteration method. So for example, if the initial approximation is 0, 0, 0 means, what to do in the first equation, you put x2 is equal to 0, x3 is equal to 0, xn is equal to 0, all are 0. So value of x1 is here, b1 by a11 in the first iteration. That means when n is equal to 0, x1 to the power 1 means the first iteration, there is the value of x1. All the variables are 0, so b1 by a11. For x2, what to do? There, for x1, you got this value, b1 by a1, that value are substitute. For the remaining variables, it is 0. For x3, this b3, for x1, this b1 by a1 is that. For x2, you got the value in the previous equation, that is substitute. For remaining variable, 0. You continue like that. At the end, you get the value of xn. So this is what Gauss-Seidel method. Now come to the Jacobi iteration. How the change is seen. Look at this. For the first equation, same iteration process. What you got the answer in the nth iteration, you have to substitute it. In the next equation, what to do is, there also, in the right-hand side, what is the answer you obtain in the nth iteration? There is no n+1 here. Here, x2 you see, in the Gauss-Seidel method, it is x1 to the power n+1. But here, x1 to the power n only. Similarly, for all the equations in Gauss-Jacobi method, that means Jacobi's iteration process, what is the answer you obtain in the nth iteration? That only you have to substitute. No new values. But for Gauss-Seidel method, whenever you got new value, that values must be substituted. This is the difference between this Gauss-Seidel method and Jacobi method. And how many iterations to be carried out? That depends on the answer obtained. If you continue like that, if the exact answer obtained, then what happens? In the next, same answer will be repeated. So once you got same answer or very close answers in two consecutive iterations, you can stop the process. So that is what Gauss-Seidel method and Jacobi method. So both the methods simultaneously explained. Now let us see some problems. So if the question is Gauss-Seidel means you should know how to proceed. If it is Jacobi iteration means, then you should know how to proceed. The first two steps same, only the third step, step 3, the change of note. for the nth Jacobi method, what is the answer obtained nth iteration? That must be substituted in every equation of that system. But in Gauss-Seidel method, in addition to that values, whenever you new values obtained, that you have to substitute in the next equation. That's only the change. Now let us take some examples in both cases. So suppose that it's asked to solve one system of equations by Gauss-Seidel method. The first problem is here, using Gauss-Seidel iteration method, solve the system of equations. Three equations are given with three unknowns. First equation is 10x plus y plus z is equal to 12. Second equation is 2x plus 10y plus z is equal to 13. And third equation is 2x plus 2y plus 10z is equal to 14. Whenever a problem of this type is given, if to use this iterative method, either Jacobi method or Gauss-Seidel method, whatever the method here, first step you have to note is that whether it is diagonally dominant. Diagonally dominant means the first equation, the coefficient of the first variable, that should be larger compared to the remaining two coefficients. Here you see the first equation, coefficient of x is 10. Y is here, coefficient is 1. Here it is 1. If you add these two, 1 plus 1, that is 2. It is less than 10. So here this condition is satisfied. The second equation, coefficient of the second variable. Coefficient second variable is here. Second variable is y. Its coefficient is 10. This is larger here compared to these two. Coefficient of x is 2 here. Here it is 1. 2 plus 1 is 3. That is less than 10. And what about third equation? The third equation, coefficient third variable, that must be larger compared to the sum of the remaining coefficient. Here, coefficient of x is 2. It is 2. 2 plus 2, 4, less than 10. So this condition satisfies. So you can use this iterative formula. Sometimes in the exam, what they do is they interchange this. Instead of the first equation, they give this one is the first equation, this is the second. In that case, you have to rewrite the equation in such a way that this condition is satisfied. That you have to keep in mind. Otherwise, if you use this iteration process, the beginning they give 0 mark. So this is very important. You have to note that for Gauss-Seidel method and also Jacobi method. Once this condition is satisfied, rewrite the system in the iterative form. Iterative form means we need the iteration formula. For that, for the first equation, write the value of the first variable in terms of the remaining variables. So the given equation can be written as, if this diagonally dominant, from the first equation, write the value of x in terms of the remaining variables. How we get this 10x is equal to, take these two variables right hand side, we get 12 minus y minus z divided by 10, that gives the value of x. So the first equation can be written as x is equal to 12 minus y minus z by 10. So that first equation, because it is diagonally dominant in this order, if it is that, then we can go. The second equation, coefficient of y is larger. So write the value of y in terms of the remaining two variables. So here 10y is equal to, it is 13 minus 2x minus z divided by 10, that gives the value of y. So what is the value of y? Y is equal to 13 minus 2x minus z divided by 10. From the last equation, the last variable must be written in terms of the other two variables. So what is 10z is equal to 14 minus 2x minus 2y. So z is equal to, divided by 10, it gives 14 minus 2x minus 2y divided by 10. So first step, what you have to do is rewriting the system in this form. This is the iteration formula, right? How to get the value of x, how to get the value of y, how to get the value of z. First should know x is the first variable, y is the second variable, z is the third variable. Once you write like this, you have to start this iteration process. First you should know whether the initial roots are given or not. In this case, then nothing is mentioned, just ask you to solve this. If it is the case, you are free to assume the first approximate root. So you choose the root as 0, 0, 0. X to the power 0 meaning is that the initial root. Y to the power 0 means initial value of y. Z to the power 0 means initial value of z. We are assume this one as 0, 0, 0. Please mute that. Some other voice just hearing. Okay, so take 0, 0, 0 as the initial root. So from the first equation in Gauss seidel method, what to do? For y is equal to 0, z is equal to 0, this value of substitute. So we get the value of x. So in the first iteration, starting the first iteration, put y is 0, z is 0. So what is the value of x? X is equal to 12 minus 0 by 10. Means 1.2 you got. That is the value of x. To get the value of y, what to do is, for z, you have to give that old value 0 only, that initial approximation. But for x, you got the new value. What is the value for x? You got 1.2. That value substitute here. So value of y is here, 13 minus 2 into x. X is equal to this new value, 1.2. For z, no new value is there. So this initial approximation, 0, I take it, 0. So what you get? This is 13 minus 2 into 1.2 divided by 10. That is 1.06 we get. This is the value of y. Now, to get the value of z, z is written in terms of x and y. For both x and y, you got new values. So x is your 1 point is there, y is 1.06. That value substitute here. So we get z is equal to 14 minus 2 into x. X is equal to 1.2 minus 2 into y. Y is equal to 1.06. So I got z is equal to 0.948. So this is the values of x, y, z in the first iteration. Because it is not exact answer, iteration process means we get slowly the answer and finally it approaches the exact root. Some approximate answer you got. X is 1.2, y is 1.06, z is 0.948. This is the answer in the first iteration, right? X, y, z is equal to 1.2, 1.06, 0.948. Now to improve this, we shall go to the second iteration. In the second iteration, what to do? This is taken as the initial root. From this root, go for the values of x, y, z, again using the same formula. So the second iteration, how to get the value of x here? For x, it is the formula, written iteration formula, 12 minus y minus z by 10. For y, this value of substitute, you got the new value for this. Y is equal to 1.06. This is the value for x, this is the value for z. So y is equal to 1.06 minus z. Z means 0.948 you got. So I got a new value for x, that is 0.9992. Earlier value was 1.2. Before that, I got 0. Initially, I chose to be 0. Next, I got 1.2. Here I got 0.992. Now, to get the value of y, take the second equation. There, put x is equal to, this is 13 minus 2 into x. X is equal to this new value. For minus z. For z, there is no new value here. So, old value is there. What is the old value here? 0.948. That you substitute. If you substitute, you got this relation. On simplification, use your calculator and you do your calculation your own self. But after that, you can do. Now you just listen and write the answer only. Later, you can try yourself and see what the answer. If any correction is there, you can correct it. So this value I found is 1.00536. Now to get z, what to do? For x and y, you got new values in the second iteration. That value of substitute here. So z is equal to 14 minus 2 into x. X means 0.992 minus 2 into y. Y is equal to 1.00536. If you substitute it, use your calculator and see what this value I calculated. So you see this value is correct or not later. Now you just mark it. That's all. So it is 0.999088 got. So in the first iteration, what the answer you got? 1.2, 1.06, 0.948. These are the values of x, y, z. The next iteration you got 0.992, 1.00536, 0.999088. This is the answer better than the previous one, but not exact value. So this is the answer obtained in the second iteration. So in the second iteration, I got the answer. X is equal to this much, y is this return, just again, z is equal to 0.9908. But how to believe whether this answer is correct or not? We believe this one in two consecutive iterations if the same answers obtained. Here he got 1.2 for x, here he got 0.992. That's far difference. So we are not satisfied. So I'll go for the third iteration. The third iteration, what we will do? Again, this is that formula to get x, y, z return just from the given equations. For x, this is the formula 12 minus y minus z minus 10. For y, this value substitute. Now new value got 1.00536 and for z 0.99908. If you substitute, you get a new value for x. And again, that new value substitute in the second equation for to get the value of y. For z, the same value. That gives the value of y. Similarly for z, you continue like that. So we get that in the third iteration, the value of x, y, z as I calculated. You can check it later. So for x, I'll get 0.99955 and y is equal to 1.0018 and z is equal to 1.0000453. This is the value you got in the third iteration. Once again, if you improve that, if you want to improve this, because this also far away from, not far away, somewhat better than the previous one. One more iteration, let us start. So if you carry out one more iteration, I've seen that the value you get like this. For x is 0.9997. For y, it is 0.99999 you got. And for z, 1.0005. Very close to this. All right? Very close to this you got. If you get enough time, we can take one more iteration. And I've seen that in that iteration, I got the value as x is equal to, it's 1.0000 like that you got. And y is 1.000, z is 1.001. So I take this 111. Again, if you carry out same answer repeated. So 11111 because this is the exact value. So when exact value is obtained, what happens? In next iteration, we get the same answer. So the solution for the system by Gauss-Seidel method is it is 111. But if you just practice from this third iteration itself, we can guess it is very near to 1 1. That idea we get using Gauss-Seidel method. So in the third or fourth iteration, we get the exact answer. But sometimes the same problem they ask using Gauss-Jacobi method, how to solve. This one is Gauss-Seidel method. If the question is find the solution by Jacobi method, means starting point same. Only how you get the new value from the right hand side equation, that only the change. So you should know what is this Gauss-Seidel method. So in the fifth iteration, you got the exact answer, 111 you got, right? Now let us see in the next method, how far away from this, right? So the next problem, so the solution for the system is, I can assume that it is x is 1, y is 1, z is 1. So this is the answer you got in the fifth iteration. So I conclude like that. So this is how to solve a system of equation by Gauss-Seidel method. Now, the same problem I given, but using Jacobi's iteration method, how to solve.